Hello Year 10, today we're going to be going through the exam pro questions that were set a few weeks ago on the energy changes topic. So here is the first question for you to have a quick read through. If you need to pause it, please do. And then I will start going through some of the answers and highlighting as a class where we did really well and where we need to improve our exam technique and where there may be some gaps missing in our knowledge. So that was the first part of that question. And then we did really well with this section. Almost everybody got that it was an independent variable, the volume of sodium hydroxide that was being used. And most people got continuous as well, because we could have picked any volume on that scale. We could have had 32.7 centimetres cubed if we wanted to. And then question B here, where we're calculating the change in temperature. We've been given the initial temperature, then reading the scale to get the final temperature and calculating the difference. Everybody did extremely well with that, which I'm really pleased about. Part C, people again did really well at measuring down from this point rather than measuring down from any of the two crosses. So that's something to be really pleased with. Part D, we had a few people that did really well at this and a few people that put something sensible, but unfortunately the mark scheme is quite picky with the sorts of answers that they're looking for. So it asks us to suggest one error that could have been made in the method that caused this anomalous result, shown here by my pen. So the first thing that they're looking for is, if you go back to the method, it specifically asks you to stir the mixture. So one error that could have been made is that they did not stir the mixture. So that could have been a possible answer. The other possible answer is it asks you to measure the highest temperature that it reaches. And you'll remember we did this in a practical before we broke up. So the other error that could have been made is that we did not wait and measure the highest temperature. Now, you didn't need to write both of these. Either of those would have gotten you that first mark for this section D. Now, part E for this question was a calculation and took us back to our chemical calculations topic, which we did before this one, that we started back in January. So reading the question, I'll take a different coloured pen. It tells us that the solution contains 80 grams of sodium hydroxide per decimetre cubed. It then tells us that the student uses 40 centimetres cubed of this, that we need to calculate the mass of how much sodium hydroxide is in that 40 centimetres cubed. Now remember, our first step with any calculation is converting centimetres cubed into decimetres cubed. So to do that, we divide by 1,000. So we have 40 divided by 1,000. And this tells us how many decimetres cubed the student is using. Put that on the screen there. And then from up here, we know how many grams is in each decimetre cube. So if we times those together, so this is how many grams per decimetre cubed. So for this question, we can use our equation that concentration equals the mass divided by the volume. And all that we've done here is, because we're calculating the mass, We rearrange the equation to get the concentration times by the volume equals the mass. So this bit is the concentration, the 80, and this bit here is the volume, but importantly in centimetres cubed. If we pop this into a calculator, we should get 3.2 grams. So that is worth 3 marks. You'd have 1 mark for rearranging this equation here and converting this into decimeters cubed, times it by the 80, and we have our final answer of 3.2. Okay, looking at question 2, everybody did extremely well on this question and identified the product as water. And then we have an energy level diagram as seen in lots of the videos we've been working on over the last few weeks. So let's get this question side by side. So we've got our energy level diagram, and this first part of the question asks us which arrow shows the activation energy. Now almost everybody was able to identify this as the difference between the energy level of the reactants and the peak on the diagram. So that was A. And then in part 2 it asks us which type of reaction is shown by the energy level diagram. And almost everybody got this as exothermic, which is fantastic. And then, so that got us the first mark. Where people were having problems was describing the reason. So lots of people just had their wording slightly wrong. And I could understand that you knew exactly what you were talking about, but you just needed to get that wording right to get the mark in the exam. So simply, all we have to do is state that the energy level for the products is lower than that of the reactants. So just one sentence, that the products are lower in energy than the reactants. And that gets you both marks then. And then we have this calculation. So we are given the value of A and of C, and we need to calculate the value of B. So from our diagram, we can see that B is the same as C minus A. So we know that B equals C minus A. So we can just substitute these values in as B equals 3,230 minus 1,370, which equals 1,860 kilojoules. So lots of people got this right, but I'm really pleased to see that everybody who submitted their work to me gave this question a go. Whenever you see a calculation question, even if you're not sure what to do something with the numbers. It's so much better than leaving an answer blank. For part C, the first part of the question asked you to look at 2 scales and record the start temperature of the water, the final temperature and the increase. And I'm really pleased that all of you managed to do that really well. And then if we go on to the next part of the question, it asks you to look back at the figure in the previous section. So I've popped it here. And it asks you to tell you what M is. So if you look at the units, it's in grams. So it's asking about the mass of the water. So we know that the mass of the water is 50 grams. That was a nice, easy mark. Lots of you were looking at which of these values was anomalous. So if we look, every single time it goes up, it goes up, it goes up. Here, however, it went down. But this value is much higher than any of the other ones. So it's this value, and they let you either put 20.1 kilojoules, or you could name the alcohol, which is propanol. Then for the next bit of this question, it asks you to look at the relationship between the number of carbon atoms in one molecule of alcohol and the heat energy released. So if we look, as we go down the table, it increases. So there are more carbon atoms in one molecule of pentanol than there are in methanol. Then if we look this side, generally this also increases. So there's more energy being released from this alcohol than there is from this one. So we can say that as the number of carbon atoms in one molecule of alcohol increases, the heat energy released also increases. Excuse my handwriting there. Okay, then the next bit of the question says that the value in the data book is this. Suggest 2 reasons why the student's results to be now is lower than the data book. So if it's lower, that means we didn't measure all of the energy. So some might have been lost, or some might still be in the fuel. So looking at energy loss, this could be for 2 reasons. It could be because there was no lid, or there was no insulation. If you remember back to the practical that we did, we used a polystyrene cup because it was a better insulator than the glass beaker that was used in this experiment. And we talked about how if we'd used a lid, that would have improved the insulation further. Now, you could put both of those and get both marks, but you could also talk about how it could have been incomplete combustion, which links to the topic we are currently doing on organic chemistry. It could also be that there was an inaccurate measurement made by the student. Remember, accuracy is all about how close you are to the centre of the bullseye, whereas precision is how close all your darts are to one another. And then finally, you could say that there was no repeats, so they couldn't calculate a mean. And then this question is now probably much easier now that we've started our organic chemistry topic, because we know that this molecule that I'm drawing now is called butane, and it's an alkane. So in an alkane we have both carbon-carbon bonds and we have carbon-hydrogen bonds. The only difference between an alkane and an alcohol is the presence of this bond here. So this is the functional group of the alcohol.